Hey YouTube, what's going on? I'm Greg. Welcome back to my machine shop. Today we're going to be working on the block cover. This is the final part we need to fabricate for our crankcase assembly in our Wallaby 30cc engine. We're going to be looking at both manual machining and also I'm going to introduce you to my CNC machine. Since this is the last part of our crankcase assembly, we're going to have to find a new assembly to work on. So the next series is going to be on the crankshaft assembly. All right, let's look at the print and then make some chips. As a reminder, the plans for the Wallaby 30cc engine are free to download from my website, gregsmachineshop.com. Just click on the Downloads item on the menu. Let's look at the manual machining of the block cover first. We start with a 1/4 inch thick plate of aluminum and face both sides. Whatever you end up with is fine. Here I got 0.219. Then we machine around the perimeter, leaving the outer flange 3/32 of an inch thick. There is this little feature here that is machined out. This is to clear the oil filler. We then have a series of holes all the way around the perimeter, and they are centered on the part. And lastly, there is a feature here consisting of 3 holes for the coolant flange. These holes here will be drilled and tapped for a 632 to hold that water coolant flange in place. If you're manual machining your block cover, you may also want to take a look at the cover for the CNC machine. The only difference really is that the version for the CNC has these fins cut in with a 1/16 inch end mill. You could do this manually if you'd like. The dimensions for the fins are located here. What I recommend on these 14 holes is to drill them under size 0.070 for the 256 screw and use this as a drill guide onto the block. And once all of the screw holes are drilled into the block, then we can drill these to the 089, which is a clearance hole for a 256 screw. I wanted to talk a moment about the choice for a 256 screw to hold the block cover on. It's really the smallest screw that could be used. You could use a 3 series screw or even a 440. There's enough room here on this flange to allow the use of 440s. If you're manually machining your block cover, you can go out to the machine shop now and get started on making some chips. For those of you using the CNC machine, you can stick around and I'll show you how I machine mine. I face a piece of aluminum on both sides that has been cut slightly larger than the final part. I bond it to a piece of wood secured in my CNC vise with 5-minute epoxy. I have an 1/8 inch hardened dowel pin mounted in the collet of my spindle and use the electrical connection between it and the workpiece to let me know when I've touched off the side of the part. I'm using Linux CNC. For my CNC router controller, I select the X-axis, then the touch-off button, then click OK, setting my X-axis 0 point. Then I repeat the process for the Y-axis, moving my pin into position and touching off on the edge. I don't have a convenient place to clip my secondary probe lead to the part, so I hold it into position by hand. Select Y, then touch off, then OK to set the Y-axis to 0. Then we use the same process on a mill with a DRO, touching off on the opposite sides, splitting the difference on both the X and Y axes, and we end up with our 00 XY point set to the middle of the part. Finally, I move the spindle to all 4 edges of the work part, checking the screen to make sure that the 3D model falls within the confines of the workpiece. Now it's time to load our first tool, a 1/4 inch end mill, touch off on the top of the part, setting our Z-axis, and then begin our roughing. For the block cover, I used a 1/4 inch end mill for roughing, removing most of the material. Then I continued with that 1/4 inch end mill in a horizontal operation to finish the flange surface and the top surface. And also used it to machine out most of the material in the large hole. Now it's time to load the next tool. But I've machined off the top of my workpiece, essentially losing the reference point for my Z-axis. So I go over and touch off on the top of the vise, write down the value of the Z-axis at this point, load the next tool, touch off to the top of the vise, and then set the Z-axis to the same number. The 16th inch mill was used to machine the fins and the 70 thousandths holes. And finally, I used a 3/32 end mill to machine the outer perimeter. As I mentioned before, the plans can be downloaded for free from my website, gregsmachineshop.com. The 3D models and the Fusion 360 files used to machine it can be downloaded from my Patreon page. I have the link below. But we're not done yet. We take our freshly machined block cover over to the mill and clamp it in the vise with the block. We carefully line up all of the sides and then match drill 2 holes on opposite sides, 70 thousandths in diameter, for a 256 tap. We tap those 2 holes and secure the block cover in place, then drill the remaining 12 holes in the block. Finally, we can drill all the 14 mounting holes to their final clearance dimension, 89 thousandths, for a 256 screw. And that completes the block cover, the final component in our Wallaby crankcase assembly. Next time we'll take a look at the crankshaft. Until then, I'm Greg. Thanks for visiting me in my machine shop. Take care.